Fantastic. Thank you very much for coming here. I know it's late in the day. We're all just hanging in to get to the after party. I'm part of that. Bear with me. I'm trying to get through this and hopefully give you some nice bits and pieces here and there that you can actually take away and learn from. I want to talk about web APIs. With all the other topics here, probably not the most exciting and whatever, but I think it's actually really interesting once you get into it. I started giving this talk a while ago. It's almost 4 years ago. And obviously it evolved over time since then, but the core motivation still stayed the same. I had two core motivations why I'm giving this talk. The first one was in the team at the time, but even outside of the team when I was at meetups or conferences, in conversations, surprisingly often, surprisingly quick, we ended up in spaces where people would say like, we can't build this because we would need to go native, or we just build a mobile app because we needed X. And I say surprising because it's interesting to see how often that's actually not true. And it comes from, a lot of the time it comes from 5 to 10 years ago, the browsers didn't have that functionality, but browsers have caught up massively since then. And it's often just in the lack of awareness of like what browsers are actually capable of these days. So this is one part of it. I just want to showcase some APIs, some of APIs that you might know. Some APIs you might not know. Even if you know them, you might not think about them actively, how to apply them, and how you can use them to actually enhance the user experience. So hopefully some of them you can take away and actually practically just put into your products. The other motivation is then taken from there. When you show people those APIs, they often jump into the other extreme of like, cool, I have all these APIs to play with now. I throw them everywhere and make all the functionality kind of rely on them. So a big part of what I want to kind of advocate here is the idea of progressive enhancement. I'm a huge fan of progressive enhancement. And as a definition, Mozilla, I think, pretty much nailed it. So they write on their website, progressive enhancement is a design philosophy that provides a baseline of essential content and functionality to as many users as possible, while delivering the best possible experience only to the users of the most modern browsers. And I think there's a few very key points here. For one, progressive enhancement is a design philosophy. So it's an active choice that we're doing of actually thinking about as we're building our products. It's providing the baseline of essential content to as many users as possible. I think this is beautiful in multiple ways. One is like we do want to have as many users as possible have availability to our core functionality, but it's also already implying like we can't give all the users access to that, but as many as possible should always be a goal. And then delivering the best possible user experience to the one with the most modern browsers is obviously Mozilla, so they focus on the browser. But you can spin that further. You can think about the user being in the most perfect environment and circumstances, like not in a noisy room or not in whatever. And you can even think about like the user has access to the input devices that make the user experience the best or whatever. So like you can spin that further and further. But why I'm mentioning it here is because I want you to look at all of these web APIs that we're going to look at through those glasses of like, how can I use them to progressively enhance the user experience of my app, not to make it rely on that too much, that users that don't have access to that functionality just can't use your app at all anymore. The other thing is, I think talking about web APIs just in abstract doesn't make much sense. So I actually have like a demo application that I built just for this talk to kind of demonstrate how you can actually use those APIs in real life context. It's called stopme.io. It's an actual thing. You can go to it and play along if you want to. It's the ultimate SaaS product, SaaS in this case obviously standing for Stopwatch as a service. And it's really just that. It's a dumb stopwatch app that starts a timer, stops a timer, all of that stuff. So it's obviously smaller than what you would be building in your day-to-day in your products, but I think it's big enough to still give enough context to see how these APIs can be applied and how it feeds back into that progressive enhancement and thinking about the user experience at the end of the day. Cool. So I know this is late in the day and the energy is pretty much floating away. But I really just want to talk about a bunch of web APIs. So this is going to be pretty rapid fire, going through them, look at some code, look at the example, and then move on. So please bear with me while we're going through that. I tried to put them into categories. Those categories don't necessarily make sense, but you can see that we're progressing towards more advanced APIs in the end. The beginning is more just observability, like JavaScript being able to actually observe a bunch of stuff in your application. And the first one, a lot of people might actually already know. It's been around for a while. It's even been popular, like it has a phase of popularity. It's a resize observer and the intersection observer. Getting some feedback. Resize observer, in a nutshell, it basically allows you to listen to any DOM element on the page, and whenever that element changes its size, you get a callback, and you can do whatever you want with that information. You get the new size of the element, you know which element changed, all of that stuff. I hear from a lot of people that this API is now useless because we have CSS container queries, which is partially true. Container queries helped a lot with if you have styling related stuff where you want to style an element differently based on what the element's size is. Perfect for container queries. But there's so much more you can do where you might actually want to have different behaviors, different functionality, different stuff in your JavaScript, where this API is still extremely powerful. In a very similar way, the intersection observer allows you to listen to a DOM element and basically detect whenever it comes or leaves the viewport, like comes into the viewport or leaves the viewport. Again, a lot of great interactions that you can do with that, knowing that the user is actually seeing a certain element at a time. The other reason why I'm mentioning these APIs is because they're still super relevant for all of these fancy frameworks that we're now using, because they're using these underneath. Like, you might not use these directly, but front-end frameworks like Astro and Quick is a famous one for going really extreme with the code splitting, but then using APIs like the Intersection Observer API to say, like, okay, I'm loading this chunk of JavaScript that was split out from the callback from a button once the button is actually visible on the page. So these APIs, even if they're not directly in use, or like if you don't use them directly in your application, being aware of them and being aware of the power that that gives you in JavaScript is really important. Like I mentioned, these APIs have been around for a while and are widely supported. So this is probably a good time to talk about how do we know which APIs we can use and which one we can't. So in this talk, I'm using the baseline kind of paradigm that Mozilla started using and working with Google and other platforms. It has different stages. So this is the badge that you will see on the MDN docs and other places. Widely available basically means the feature is listed, is in all of the modern browsers and has been in those browsers for at least 2.5 years. So that should give us a certain confidence that, given how auto update works in browsers nowadays, that most of the users will have access to these features. The newly available still tells you, okay, all browsers started adopting this feature, so they're in all latest versions of the browsers, but they haven't been in there for 2.5 years yet. So maybe be a little bit more cautious. Again, approach all of this with the backwards compatibility. This is progressive enhancement. Then you're going to be good. And the limited availability is basically just telling you not all browsers have adopted that. One thing to note, this is just looking at the major browsers. So if you have a product that's catered for a market that uses like more outside of that browsers or the Chinese market or whatever, definitely still do your due diligence and look for those numbers. The whole idea here is to take what we used to have with Can I Use? I don't know, probably many people heard of that. That's still super valuable because it breaks it down even further. But this is a more accessible, kind of consolidated view of looking at things. So you're going to be seeing these at each of these APIs that we're talking about. And if you pay close attention, you might even see a pattern of certain browser support. All right. You can go much further than just observing the DOM that's on the page. That's cool, but it's not really exciting. One of the APIs that's, again, also been around for a while, but I've seen too many people not know about or not use it, is the Page Visibility API. And basically all this does is it tells you whether or not your current page or your app is currently the active tab in the browser, or if the user switched to another tab and it's running in the background. So to actually put that into context now, which I promised I would, I have the app open, the Stopwatch app, and we can actually see, say my user starts a timer, but then that timer goes for a while, so they don't want to just stay on that page, they want to do other stuff on the internet. They can switch the tab, and I can listen to that visibility event and basically tell my app, okay, cool, put the timer in the title bar. I don't know how well you can see it, but basically it allows me to make it more accessible to the user to be like, okay, I can still browse the web and have an eye on my timer and that kind of stuff. In your applications, there might be much more simpler things, like you might be polling your API to show like real-time data on your dashboard and stuff like that. That's obviously like heavy on the network and like your server. So you might want to detect whenever the tab is in the background to stop the polling and start it again when your site becomes active again. So again, the ability to listen to those simple events and kind of have the full control over what you want to do in those situations can be really useful. In a similar way, the Network Information API can give you additional information about the user's current network situation. You might know like the very basic Navigator Online attribute that's been around for ages. You probably remember it because of the way it's spelled. It's never what you thought it would be. All it tells you, it's just a Boolean that tells you whether or not the user has an active internet connection, and it gives you an event listener, online and offline, or 2 event listeners, to get notified whenever that status changes. So that can already be really useful, and you've seen that in a bunch of apps where you can just show the user, hey, you're currently offline. Some of the functionality might not work. So even in our app here, I don't know if this is a good idea, but let's just turn Wi-Fi off. So let's pretend that actually worked. And you would see a bar here that tells you you have no internet connection. I don't know why that didn't work. But I probably also... Oh, yeah. It showed up for a millisecond. But simple stuff like that, where you can just warn the user, hey, certain functionality might not work as you expected. But the actual Network Information API goes further than that. So it actually gives you a Navigator connection object that has a bunch of meta information about the current network connection. So we have the network type. So that can be Wi-Fi, that can be cellular, that can be your Ethernet you actually plugged into the wall. And that might help you identify, okay, maybe I don't want to like show the high resolution image and want to serve like a lower resolution version or like videos or whatever. You have downlink and RTT, round trip time. Those are estimates, so definitely treat them with a grain of salt, but they might still be useful for certain scenarios. And you have safe data, which can be really good. The user actively said in their device, I don't want to use too much data. Then you can definitely opt into like the lower resolution resources that you want to serve them. Again, it comes with an event listener, so the pattern is still the same. You have an object on the navigator, and then you just listen to that event, and whenever it changes, that object will have changed, and you can just apply that to your application. Battery Status API. One thing you might note is they're all very well named. We always joke about like naming things is really hard. It's literally on the tin what they do. Battery status gives you information about the user's battery status. So it's asynchronous, so it's slightly different, but the idea is still the same. You have Navigator get battery that gives you an object of certain meta information like the current level, whether it's currently charging, so that's just a Boolean. When it's charging, it will give you an estimate of how long until the battery is fully charged. If it's not charging, it will give you an estimate on how long until it's completely empty. And then again, you have events in this case for each of those attributes. You have a different event that just tells you whenever it changed. And again, if you think about it from a progressive enhancement standpoint, this can be really good if you have like long-running tasks in your application. So like cool, the user just started downloading this massive data set that might take like 5 minutes, 10 minutes. And you can see they're not currently charging the device and the battery might run out in 5 minutes. You can warn them, hey, this might not last that long. So in our Stopwatch app, if the user sets like a timer that's definitely like way too long. Oh man, these demos are not working today. There we go. You can just tell them and say like, okay, cool, you can start the timer. I'm not going to change anything, but like you might not see the end of this timer if you don't plug your phone in. Again, with both of these last APIs, like network information and battery status, it's important to understand like these are estimates and slightly, they're not super accurate. And that's actually for a reason. There's this thing called fingerprinting that most of us might have heard of. It's the idea that you can take a lot of that meta information of the user and just store it. And if you combine enough, you can identify a single user just based on those meta information. So I believe Google, like when the API first came out, the battery status API, it was extremely accurate, and I found that really useful. And then you could see over the years how it progressively got more and more inaccurate, and I believe that it's part of them combating that. The other thing that they started doing is that privacy budget, or started thinking about. So there was a proposal out there where basically the idea is that the browser vendors can give each application or each site a certain budget of how much private information they could request from a user or from a device. And if you reach that budget, you just wouldn't get that information anymore. And again, just limit the ability to fingerprint users and kind of track them across multiple apps and stuff like that. I'd say there was a proposal out there because while I was really hyped in the beginning when I gave this talk, by now they actually it's no longer active. They're no longer trying to follow that particular idea, but they're still, ironically, like especially Google, they're still very vocal about like, okay, we need to do something about these privacy concerns, especially around those APIs. All of that to say, if you use these APIs, be aware of that, be aware of what fingerprinting is, be aware that those APIs might get certain changes in the future based on trying to prevent fingerprinting. All right, the next category is more generic of like enhancing your components. And this is the category that I'm personally extremely passionate about because I'm a front-end engineer and I worked a lot on design systems in the past, on component libraries, and these are just things that just make your components have that nice little touch in the end where it just feels like, this is so cool. The first one actually doesn't really fall into this category, but it's also cool. Screen Wake Lock API. It's surprising it's been around for a while, but it's now around, like it's supported by all browsers fairly recently. I think Firefox was the last one to catch up on it. And all it really does is it allows you to tell the device, hey, I have something going on the screen. The user might not be interacting. They might not be moving their mouse or typing something in. But I want the screen to stay awake. I don't want the screen to go into screensaver. And basically all it does is requests the screen to stay alive. And this is all it does. It's sending out a request. There's no guarantee that the screen will get locked for various reasons. One of the big reasons is obviously like the device might decide, the battery's already low. This will just drain it more. And it will just reject that promise. But if you get the screen locked, then you can just wake lock on release to unlock it. And therefore you can control the experience for the user while your thing is going on. So like a good example is like videos. While you're watching a video, you're not actually interacting with your device. Like the video element, the HTML element will already control that. But if you're doing custom stuff and you're actually not using a video element, this might be something you'd be interested in. In our Stopwatch app, if I have a timer that goes for 15 minutes and my page is staying active, the user probably wants to see that timer. So I could use that API to force the app to stay, to avoid going into screensaver. What I would say with those kind of APIs, again, progressive enhancement, but also give the user control. Like in this case, it would make sense to have a toggle to allow the user to say, hey, I want my screen to stay awake, rather than just forcing them into it. Vibration API. I am a huge fan of going just beyond visual, like any kind of haptic feedback that you can give to the user, if you do it right and do it in moderation, can be really powerful. And the Vibration API, I think, is a good example of that, again, if you use it right. So it does what it says. It basically just gives you a navigate at vibrate function. And that function can receive either a number, a single number, that's then just the duration the device will vibrate for, or an array of numbers. And then it's just a pattern that you can vibrate. You can call it vibrate 0, and then the vibration stops no matter if it's in the middle of it or not. I haven't mentioned it before. You can see browser support, mostly Chrome, Chrome and Chromium browsers. This is kind of like the pattern that I hinted on. I'm not going to go too deep into it. There's actually reasons why there's good arguments for both sides that Chrome is also not doing the right thing here. Not in this particular API, but in general. But this is what you're going to see for a lot of APIs from here on, is that they're Chrome first, I guess. Again, with the progressive enhancement, that doesn't mean that you can't use them. Just use them carefully so that your core functionality doesn't fully rely on it. So with the Vibration API, in our use case, for example, with a timer, that's a great one. When the timer finishes, you probably want to vibrate the phone or the device, if it supports it, just to tell the user it finished. So they can set a timer for cooking, put the phone away, do their stuff, and they will get notified when the timer stops. And the fact that you can do patterns, and the internet being the internet, also means that there's whole websites and Reddit threads out there trying to give you patterns for your Morse codes or your video or movie theme songs and all that kind of stuff. So it's also a great opportunity for Easter eggs when you have in the Stopwatch, if you have a timer that's called something Star Wars related, you actually get the Star Wars theme as your vibration pattern in the end. File system and clipboard API. I actually included that for a few reasons. For one, I just want to show it. Again, it does what it says, file system API. It gives you access to the user, basically the file picker. It allows you to write files and all of that kind of stuff. It's something a lot of people weren't really aware of, that JavaScript actually caught up on that. We have now APIs, again, at least in Chrome and Chromium, that give us access to that kind of thing. Clipboard is very similar. The Clipboard API gives you access to read from the clipboard or to write to the clipboard. And again, for years and years, that wasn't possible in JavaScript. There was always the limitation for security reasons. Now we have APIs, and this one is actually baseline newly available, which is really exciting. The reason why I want to mention these ones in particular, though, is because of that original motivation. The whole, we have to go native to build certain things. These APIs, and some of them that I mentioned before, are really good examples that we actually come quite a long way. So if we look at those APIs here, they actually look very different, very similar, if not exactly the same as the ones that we just talked about. But all of these are actually Cordova plugins. So this is from does anyone know Cordova here? It used to be called PhoneGap. I'm quite old. This was what we used to do in the very beginning of JavaScript exploration, of writing native apps in JavaScript. Basically, all it did was allow you to basically, your app would just be a browser frame, browser instance, and it injects some native functionality, but then you would just run your JavaScript in there. And these were examples for plugins. And based on those, this heavily inspired a lot of the directions of browser APIs and where they went. And I think it's worth acknowledging that. Cordova or PhoneGap is pretty much a meme at this stage. But you should really give it credit for paving the path to exploring what we actually want to have access to in like more native functionalities, exploring the APIs and like how to make it developer friendly, and then basically helping with the adoption in all of the different browsers. The other reason, like similar with the clipboard API, by the way, like at the same time when we were like doing stuff with PhoneGap, I was still probably late on that, using applets like Flash and Java applets to do clipboard stuff and to do file uploads and all of that. And it's crazy to think about how far we've actually come, especially when you hear people complain about like our browsers and the specs and it has to go through so many stages and it's so slow. It's like we've come so far in the last 5 to 10 years. It's crazy. The other thing with the clipboard API, which we might actually want to look at, is it's a good time to talk about different activation patterns. So for the clipboard API, in the example you can see it's triggered within a click event handler. So there's different activation patterns to deal with that security concern that I originally mentioned. So the reason why JavaScript didn't have clipboard API for a long time was the idea of like it will very likely be misused, and like security was a huge issue. How we get around that is with these activation patterns. So some APIs are less of a concern, so there's no activation pattern needed. So they can just be called in any context and they just work. And then we have what we call transient activation. So those APIs only work if they are called within specific events that are called trusted events. If you ever logged like a whole event object out, you might have seen the isTrusted attribute on this. That's exactly what it is. If that's true, that means it's a trusted event that can be used to trigger transient activations. What that means is those APIs can only be used in like click handlers, mouse move handlers, et cetera, et cetera. So the user actively did something to make sure it can't be just be spammed at them. So the clipboard API is a good example for that. The vibration API is actually a really interesting example for like kind of the hybrid intermediate. So it's the sticky activation. Basically all that means is the user has to have interacted with your application within a certain time frame. So usually these kinds of APIs are we want to avoid pop-ups just triggering and immediately firing away. But once the user interacted, it's fine. You can even trigger them outside of like click callbacks and stuff like that. One famous example for that you might know is if you ever try to autoplay videos, it will not work unless the user actually did something on your site first. Then you can do it even if they don't click on it to start it, but they have to have done something before. And vibration falls into the same thing. So if you were hoping to just throw that onto your application and like vibrate away, not gonna work. Cool. This one I personally really love when I discovered it, the Eyedropper API. So this basically gives you access to the operating system's native color picker. And it's pretty straightforward. You initiate it with the window Eyedropper class. And then, again, it's a transient activation. So on a user click event, you can call Eyedropper open, and that triggers the native UI, and it will give you a callback with whatever color the user picked, or it will throw if the user canceled out or something else happens. So what that looks like is literally this. So this is the macOS color picker, so I can even go outside of the browser window, and I can just pick any color that I want. And I get the callback, and then I can do whatever I want with that color code. So this can be really useful. Like most apps have customization options where you want users to be able to put in their own brand or whatever. Usually that just come with like, oh, you have to put the hex code in. You can make it much, much easier for users by just, okay, let them open up their brand guidelines in a PDF and just pick their colors from that. It's also an interesting example. I might be spreading rumors here, but I've been told that this API was actually, or the browsers worked really closely together with Canva on this one because Canva was really like keen to get that API in. And it's a good example of like how products can actually influence and help drive those lower level APIs in the browsers. And again, if we think about it from progressive enhancement standpoint, I'm going to be sneaky here, and I have my app, my phone in the background here. I hope this works. Yes, it does work. So this is actually like, this is not an emulator or anything. This is actually a separate device, just so you can see it. And obviously my phone doesn't have a native color picker, so I can detect that, and for those devices I just don't show it. But I would still show all the other options, so I don't disable the functionality for those users. Which all kind of leads us more into that, like, oh, cool, we're now starting to do stuff that native apps often do and use. I can't count the amount of times I've built like Facebook and Twitter and LinkedIn buttons for various applications that basically all they do is just have a URL where in the URL you have like a title and other stuff that you want to share. There's actually a way better option. With slightly better support, it's Chrome and Safari. Firefox also has that. There's just some parts of the functionality that Firefox doesn't support. I think it's the files on the share data. But essentially, all this API does, it allows you to define an object of the data that you want to share. Again, we have a title, we have some text that you want to share with it, URL, and then optionally like an array of files that you want to attach to your shared stuff. And then you can just trigger Navigator Share, and it will pop up the native operating system's share functionality if it's available. And the cool thing about this is that it goes beyond you having to think about like, which platforms do I want to share to, and then do those have like URLs that I can actually link to and all that stuff. And you move it away into like an actual spec where those apps will start implementing, okay, cool, with the native share, this is how I want to display that shared piece based on this meta information, which is really cool. I used to show like the difference between desktop and mobile with that native share functionality, but then macOS caught up and now also has a native share thing. So this is what it looks like on macOS. This is the native pop-out that macOS uses, and this is I mean with decoupling. I didn't have to think about like what apps the user might have installed. It knows which apps I have installed, and it knows which apps support this share through the object structure functionality. And then these apps know how to optimize visually what you want to share to put it in the right place. So I think that's really cool. And on mobile, it's again, it also just gives users that experience that they know from all the other apps, their native apps, etc. The familiar UI and UX. In the same sense, the contact picker API can be really powerful. So contact picker, again, does what it says. It allows you to trigger the native contacts UI, and allows users to pick from their contacts, and you can tell it through the properties what attributes of those contacts you actually care about. So here we're defining, I want to have the name, the email, the phone number, and their avatar. I can define whether or not I want to allow multi-selection. And then I just trigger it, very similar to the color picker. Navigator contacts select will just trigger the native UI, and that will either resolve with the information that I want, or it will throw, and then I know either user canceled or something else happened. And again, we can detect whether that API is available or not. So on desktop, on macOS, it is not. So I don't show like a contact picker, but here on mobile, I can see that I do. And again, it just shows the native Android way to select your contacts and do stuff with it. And I think all of us have built apps where you're adding contacts to like a content management system or contact relation system or whatever. Allowing the users to actually be like, cool, I can just quickly select stuff from my device and it's all in the system. I think I underestimated this API actually. Like in one of my past jobs, we did put that into the product, and that was immediately like users came to us and was like, this is amazing, this is so cool. So really see like in whatever you're building, how can I actually put that in to make my users' life easier? Authentication, but better. There's a few authentication APIs that deserve their own talk, that actually, like, there's people just talking about that. I want to mention a couple of them here, though, because I think knowing about them is a good starting point, triggers some interest, but also like how they interact with each other can be really interesting. So the first one is a web OTP API. So one-time password. We all probably know that from various apps. It can be like the main login functionality or like a two-factor auth thing. But basically the idea is that the app sends you a code, usually via SMS, and then you have to put in the code to verify that you are you. There is a web API for that. And basically all this does is it's telling the device, hey, I just sent an OTP code. So expect to get an OTP code, and if you get it, and if I can prove that it's coming from me, give me that code. And that can be really powerful. Like, this is one of those things where I was like, wait, even I was like, surely you have to go native to actually even get access to like the incoming SMS and all that kind of stuff. But they found a way to actually make that work in a web API. So this is literally what the credentials get does. It just tells the device to listen for any incoming OTPs. The transport right now just supports SMS, but that's basically preparing it for any other methods. And then it either resolves with the code or again throws if something else happened. So the caveat here is the like, okay, how do you tell your device that this is trusted and that you should give me that code and that I can't misuse that? It all comes down to a strict format of what that SMS actually contains. So we got an example here. You can write whatever you want in this middle section of like your verification code is blah, blah, blah. But the end of that message needs to be the domain that requested this OTP code and the OTP code in that format. So that's just part of the standard. Yes. This is basically a cancellation signal. Yeah, I half removed some of that demo code. So you could cancel that promise if you know based on other things in your application where that's going. So you can pass that signal into the method. To see that in action, basically what that allows us to do is, if I go on my phone here, and I put in my number, I probably did that quick enough that no one... you can see we got an SMS, but we also get another pop-up that Chrome basically asks us, hey, Chrome wants to read a message, the message below, and wants to enter the code. So this is also another security layer in between. The user has to actively confirm that they're happy for this code to be shared with Chrome, aka with your web app. And if I allow that, I can do whatever I want with the code. I could auto-submit the form, I could do anything. In this case, I just fill in the code, but it's then fully in your control in JavaScript. Now, this is already pretty cool. Like, this is getting close to the native experience that you get for some apps. But I think where this really shines is the fact that Chrome can deal with things across multiple devices. So I'm logged into the same Google account on both devices. And if I request the code from here, I still get an SMS, but I get another notification. Hey, Julian's MacBook Pro is trying to access this code. So it knows because I'm logged in on both devices, hey, the browser on your MacBook is waiting for an OTP code. You just got an OTP code. I can share it, and it magically pops into the other device.
It doesn't request user presence on the phone again? Or
what do you mean?
Like, there's nothing happened on your phone to verify that it was you that had said that it...
Correct, but it will only send it to the desktop when I confirm that this is fine. But yeah, I'm getting that notification even if I didn't trigger that. That's true. But yeah, there's always that final confirmation step of like, hey, do you actually want to share this? Like, you just got that SMS. It matches the pattern. I also have a device wherever it lives that's waiting for that OTP code, but do you really want to share that? And that's the only caveat on that API that I would say is that final bit of the experience still feels a little bit daunting because it falls into that notification pop-up thing that we all now just know to dismiss. But I feel like in those situations, especially if you can tell the user that this is what's going to happen, it's definitely still a viable thing. And it's just really nice to have for those OTP flows. So I think it's definitely an API to keep an eye on for the future. Again, it's Chromium and Chromium only at the moment. Credentials API, Credential Management API. This API allows you to store credentials within the browser. Chrome and other browsers, they all kind of have like their password managers, so like you're likely already using them. And they do the same thing. So like Chrome already tries to detect, this is a password field, do you type in your password? It already pops up a, hey, do you want to autofill that from your password manager? This API allows you to explicitly control that. So it allows you to explicitly store stuff in whatever the browser has as their management system, retrieve information from there, and basically streamline when users come back to your application, they won't necessarily have to manually log in again if they gave access to this API. So it can be really cool. It can reduce the friction for your frequent users. And it can also be combined with kind of like the next API that I want to talk about, which is Authentication API, or Auth-N for short. Both of these APIs are widely available. Another reason why I really want to mention them, more awareness, more adoption. Authentication API, the idea is basically to move to the next step, and what I also see as the future of authentication, it's passwordless. Like, you don't have your email and password, not even your federated logins via Google or Facebook or whatever. You have other mechanisms that you can use beyond that. And good examples for that are fingerprints or like your parents on the phone or whatever. Exactly. Like that's more the techie side of things. If I was building an application for non-devs, I would not expect them to have like actual hardware while they're running around. But that's also a good example of stuff that's basically not storing a password on the actual application's database or whatever. There's a bunch of very obvious reasons why that's good. If there's no password in the database, there's no passwords that can leak, all of that kind of stuff. But it's also, again, just leading to the user experience of like, if I can literally just log in with my fingerprint, easier, better, more secure, everyone wins. And the Authentication API plays nicely with the Credentials Management API because you can store these passwordless authentications in the same way. And all you're actually storing on your end is the public key that you're using to compare, say, the fingerprint that's entered to like basically the information that you get from the browser about the credentials. Again, I'm not going to go too much deeper in here because I don't have the time for that. But if that's something that's interesting to you, I highly recommend looking these up. There's really good, really cool demos that let you play around with that and let you see how to use it. The other thing that I would say, don't get discouraged by, some of those might look quite complex, especially the Web Authentication API if you just look at the spec. You will very likely not use them directly. And there's libraries out there that basically build on top of that make it really easy to do both the client and the server side without too much hassle. This is one of those demos that I was talking about, where you can also see it in action. So like, basically, whenever you request those credentials, it will pop up the native UI on whatever device you're on that gives you those native options to authenticate yourself, be it fingerprint, be it through your other device, the pattern on the phone, whatever. Cool. How are we doing with time? reasonably. I have a bunch of honorable mentions, so I'm going to probably race through them. Most of these APIs that I just talked about, I feel are very applicable to most applications that at least I've built in the past. These are more edging towards like, okay, cool, they're worth playing around with, or you might be building things that actually go more into those directions and they're more useful for you. The first couple of ones actually, no, I mentioned that, going more into the like, I really just want people to know about these. It's improving existing stuff mostly. So the the Internationalization API, again, been around for a while, but it's just worth repeating. Like the more people know, the better. It's mostly famous for is allowing you date formatting and time formatting. So it comes with like really useful tools across locales to do your normal like date time strings, but also relative time formats. So like in 10 minutes or 2 years ago, in all the languages you can think of. So that's really powerful. Again, a good example for APIs that you might not use directly, but if you're using third-party libraries to do your date formatting, look for the ones that use that API under the hood, because they will be so much smaller and so much more powerful. It's also really good at number formatting, so that goes in the same direction. Different locales, different countries do number formatting differently. If you use the Internationalization API, you get that out of the box as like a core JavaScript API. It does numbers, it does currencies, it does all the things, but there's also so much more to the Internationalization API. There's segmentation, there's lists. I don't know how often I've written a array join comma to just concatenate strings to a list. That's not how lists work, especially not across different languages. There's very good utils to help with that kind of stuff. Pluralization, et cetera, et cetera. So definitely worth exploring. Temporal API. Huge disclaimer, it's still in stage 3. It feels like it's been in there forever. I might be doing a discredit here. I'm still hopeful that it will get out someday. The idea is to basically, we've acknowledged that the date API in JavaScript is less than ideal. It has a few flaws. The temporal API is trying to solve that. And it also comes with some really cool stuff like date manipulation, like a helper function to add a certain amount of time to your current date, et cetera, all the stuff that you're used to if you're using libraries like Moment.js, anyone? Datavan, like all these JavaScript libraries that already abstracted on top of it. It took a lot of inspiration from that to bring into the core API. It's very similar. The navigation API is looking at the current window location stuff. There's a bunch of things that can be improved there. The new navigation API tries to tackle those. Most prominent here is that it actually does the events asynchronously, so you can actually start awaiting navigator back, forward, push, etc. And it gives you a bunch of new event listeners. So again, it's probably something that your routing library will use under the hood, but it's exciting nonetheless. I've been told I have to put AI into my talks. I was skeptical of this first when I saw it. I'm kind of warming up to it now. So I don't know if you've heard about it. Chrome is playing with a built-in AI in the browser. So you can see it's not available anywhere. It's exciting. But it is in Chrome Canary. So you can experiment if you want to. You have to turn on a bunch of experimental flags in your browser settings. You have to download the model manually. But once you've done that, you can play around with a range of APIs that they provided. And one of them is what used to be the prompt API. It's like the language model API that they call it now, that gives you basically access to, in-browser locally, a model that you can run your prompts on, which can be pretty cool. Like in our Stopwatch app, it definitely needed, like we can, no. Yes, I do not. You can see, again, progressive enhancement. I only show it if it's available. And it definitely needed a bot that I can tell what I want to do, and it figures out how much time that actually takes. So let's see if that actually works.
So one thing to note is, obviously, because it's downloading the model locally, it's using like the smallest model it thinks is feasible. So this is, I'm pretty sure, running Gemini Nano. It could even be like a version of that. It's still pretty large. So I don't see it in the near future that people will download that with their browser. But if it's there and if it's available, it's a cool thing that you have access to. In this case, so this is what it gave me back. So I basically just prompted it with like, hey, you're a stopwatch and you're getting a command and give me the time for that. It also comes with an explanation of why it came up with the 11 minutes. 11 minutes is pretty, well, it said hard, but like it's going to be hard. Well, we can also like slow cook beef. Again, for the stopwatch, it's definitely overkill. But there might be applications, especially if you're more in the like browser extensions kind of thing, where some of these API can be actually. Yeah, that's going to be raw. Yeah, so don't use it for like critical stuff, I guess.
Does it hook into the OS with the LLM? So, like, if you're on a Pixel and you've got Gemini built in?
I do not think so. I could be wrong. Like, this is also still very early days, so they're still exploring that. There's a range of different APIs that they're working on, or again, that they're exploring. I think right now it's confined to you have to install that model, that specific model that they want to experiment with in your Canary version. I can imagine that they're open to the idea, at least within their control, of like, if you have our model somewhere else, sure. I don't think they will give you access to any other like, competitors' models. But you can see here, like there's, beyond the language model, there's other APIs like writing, like generating text essentially, rewriting, summarization. So I can totally see those being useful, again, especially in the browser extension context. Language detector and translation also. Yeah, I can see that, but not at the expense of having to download like half a gig of a model every time. Another API that closely ties into like AI-related stuff is and has been getting more and more traction recently, as far as my Twitter feed goes, is WebNN. So Web Neural Network API. The idea is basically to give us more access or closer access to the hardware, so we can actually run and train models locally to certain extents, at least. This is kind of like a whole movement of browsers thinking about ways how we can get access closer to hardware. So I don't know how legible it is, but like it's basically the whole idea. Cool, your browser API sits somewhere, and then it lets you access hardware for certain things. We've done that for a while as well, like WASM, WebAssembly, giving you access to the CPU has been around for a while. WebGPU, to give you access to the GPU, is the same idea essentially, where WebNN basically tries to make the difference is A, it would give us access to NPUs when they're available. Again, for neural networks, that can be pretty powerful. But they actually, with the spec, they went further. And say like, okay, cool, the middle layer in between can actually try to be smart about it. So based on whatever you want to do, it can then defer that task to the CPU, the NPU, the GPU, or whatever, based on your device, based on the current capacity, based on whatever. So I have a link to there's a really good YouTube video from the Chrome team when they released that API where they actually explain a lot of the motivation behind it. It's also a collaboration with Microsoft, I believe, and all that stuff. And it leads to that, like talking to your hardware, it's just a thing. Like if you're building applications that do have hardware components related to them, this can be really powerful. There's a lot of APIs out there that's been there for a while. Most, if not all of them, are pretty much Chrome and Chromium only. In fairness, I think a huge reason of that is that the whole ecosystem around building native applications with JavaScript, think your Electron, think your other like similar apps, they all run Chromium inside. So like the Chrome team has a huge incentive to drive the innovation on those API forward, where Safari and Apple don't really have that. They want to push more in the other direction of like, just build a native app for that and pay us money while you do that. Web GPU, I just mentioned it. It basically gives you access to the GPU, which for certain computations, especially if you have stuff that you want to render things to canvas and stuff like that, can be really powerful, speed things up massively. WebXR, if you're building augmented reality or virtual reality, this actually gives you access to a lot of that stuff of like accessing your scenes, manipulating your scenes. Can be really cool. NFC. I'm not going to name the hotel because I'm not getting sponsored by anyone here. But I recently checked into a hotel and I was like, oh fuck, now I need to download the app because they promoted of like, oh, you can use your phone to get into your room and stuff like that. But I didn't because their website actually used the web API to actually allow me to do that without downloading the app. So stuff like that where you have your tab on or whatever, Web NFC allows you to do that. Bluetooth, if your app connects to like wearables or any other stuff where you want to share information across different devices that are not necessarily on the same network, or you want to make it work without internet, Bluetooth is a good stop for that. All these APIs work also very similarly. USB for the same thing. And then we have the web human interface devices, which basically kind of takes the whole range of different devices that support that spec, and again, allows you just to connect to them and two-way pass information back and forth if you want to do that kind of stuff. All right, I have at least 100 more that I would love to talk about, but we're hitting the hour, we're hitting the end of the day, and I'm ready for beers. Definitely stay curious. Like, if any of these triggered your interest, there's the MDN. Come on, hide it. Okay, I shared the slides. MDN has like a whole page where it just lists all of the web APIs. Definitely encourage everyone to go there. It's a perfect way to waste like a whole weekend just tinkering around with stuff. This is a QR code and a link to the slides with all of the links to the documentation if you're interested in that. Also a link to the repo of the Stopwatch app if for whatever reason you actually want to see the code and those APIs in action. And some socials. I'm not really active on those, but here we are. And yeah, that's all I have.